Hi, welcome to HighQuest Solutions America. My name is Peter Ward. Today I'll be speaking with you about the HighQuest Solutions models TB3 and TB4 tipping bucket rain gauges. These gauges come with an integrated flow control mechanism, which we'll talk about later. The models TB3 and TB4 are the standard around the world for many local, state and federal agencies. So let's go take a look at why these gauges are so popular. Hi, welcome back. First thing I wanted to talk about with the TB3 and 4 is the construction. Here I have a TB3. I'll step back a little. The TB3 and TB4 both have an all aluminum anodized powder coated funnel and outer enclosure assembly. The base of a TB3 is a all die cast aluminum. The only difference, all the other features remain the same of both gauges. The only difference is the TB4 is constructed, the base is constructed from a UV stabilized ABS. Both the TB3 and TB4 will have a life expectancy in the field of in excess of 30 years, even in coastal areas. The next thing I'd like to bring your attention to is the finger filter and flow control mechanism. So as you can see here, we have the discharge outlet where the rain will enter through the funnel, down through the outlet and into the tipping bucket itself. The finger filter design is such that it resists blocking, and this is one of the favorite features of our customers. This is one of the major issues with tipping buckets in the field, remote locations. If they become blocked, you lose your rainfall data and it's unacceptable. So what we have here is a vertical finger filter assembly. This is about 2.5 inches tall to 3 inches tall. And what happens if there is airborne debris that's blown into the gauge or bird droppings, what will happen, it will actually sit at the bottom, form a false bottom, but it will not impede the entry of rainfall. This is a really, really important feature. The finger filter is very easily removed for servicing. And you'll also see when I take this out is what is attached to it is the actual flow control device. This is what the assembly looks like. Here we just have a stainless steel mesh finger filter, which allows small particles through, so dust, etc. We have some of these gauges in desert areas, pardon me, and that is attached to the flow control mechanism, and this is what this looks like. This flow control mechanism has a reservoir, which is just a hollowed out area inside this Delrin body. Water fills this unit and then it is automatically drawn down by gravity through the outlet. This happens at a consistent rate. So the water always exits from this flow control mechanism at the same rate. So this is really the critical point. I won't take this apart and go through the whole thing, but it's just simply a mechanism that will fill and then automatically drain. There's no moving parts. What this means is that if we can control the flow rate from this device, is that then we can correct the intensity errors that all tipping bucket rain gauges suffer from at higher intensities. WMO has stated this in many reports, as have others, that standard tipping bucket rain gauges notoriously underreport. The reason for that is simply that as a bucket is filling from the nozzle down into the bucket and the bucket is moving through an arc, additional water is still coming in here until the bucket passes the central point. So rather than go into an exceptional amount of detail, all this basically means that low rates, it's not that critical, but at higher rates, and particularly now where we have so many cloud bursts and high intensity storm events around the world, as that intensity goes up, without a correction, the rainfall data will be significantly impacted by the underreporting of the gauge. So this correction mechanism that we've had for a very long time means that the TB3 and TB4, which both are fitted with this, will hold their accuracy of plus or minus 2% from 0 to 250 millimeters an hour and 3% from 250 to 500, so that's around 20 inches an hour. So that's an extremely high accuracy for these intense rainfall events. Matter of fact, the TB4 holds the US record for the largest amount of rainfall measured and collected in the United States since records began. It's a nice achievement for our gauge. TB4, I won't go into too much. The TB4 has exactly the same outer enclosure, finger filter, siphon assembly as the TB4, only difference being the construction of the base material. So now I'd like to move on to talk briefly about the bucket material. This is our new bucket. We have had several different types of material over the years. This is our latest. It's been out for about 2 years now. This is a Teflon impregnated polymer. The reason that this is an exceptional addition to our gauges is that it's a very slippery material. Dust, water drops find it very difficult to adhere to it. Therefore, there's less residue in the bucket tips. So this has been a really nice addition, which we've added in the last 2 years. The next thing is the pivots that this bucket tips on. These are a sapphire, a compressed sapphire material, and this sapphire material sits inside of the rain gauge on either side, and the pivots actually sit inside the sapphire bearings or pivots. There is a slight amount of play, but this sapphire material is so hard that it basically will never wear out. The gauges, this sapphire pivots also give it incredibly stable calibration for long terms. We have customers that will check these after many years and find that they're basically, if you clean them, they're still in calibration. So this dual sapphire or compressed sapphire material is across all our gauges, including the TB4 and TB7. So that's covering the construction, the siphon finger filter or the flow control device, and the bucket. And lastly, I'd like to let you know about our reed switches. These reed switches are quite unique. We have dual reed switches. These are independent reed switches that output the same bucket tip but can go to 2 individual devices. In some cases, you may have this in the field as a spare. If a technician turns up and finds that the gauge is not reporting or goes out there and does not have a spare reed switch, you would simply switch the wires to the other reed. You now have an operational gauge again. So this is a nice feature. Other customers have used this by having these independent reed switches go to actually 2 separate or independent devices. It might be a radio telemetry system and an onboard data logger, or a SCADA system and a data logger. So there's some of the features. There are other ones which I'll mention briefly. We have all stainless steel insect guards on all the gauges. We have dual outlets at the bottom of all our gauges to collect water for weight or volumetric checks. But predominantly the features that most customers find that provide this accuracy and long-term stability in the field are our flow control device, finger filter, and our sapphire pivots. So I'd like to thank you for listening, and I hope you found this informative. Bye for now.